This video will continue our discussion of derivatives of vector value functions by thinking about tangent lines and deriving a few. Okay, so the thing that we need for a tangent line, and it's the same things that we need a point, so point of tangency, and then we need a directional vector. The directional vector in this case would be our tangent vector. So those are the two things we need. So let's go ahead and find point of tangency. Let's not be lazy. There we go. Okay, point of tangency. We're going to just plug in that value. So r vector at 3 plugged into this vector. Okay, so if I plug in 3, I get 3 squared is 9 plus 4, that's the square root of 13. If I plug 3 into the next one, 3 squared is 9, minus 1 is 8, that's 2/8, which is 1/4. If I plug 3 into the last one, okay, I get 3 minus 2, I got 1 up top, 3 squared on the bottom is a 9, plus 4 is 13, I got 1/13. Okay, that just gives me a vector though. If I want the point, I change my grouping symbols to describe a point. So there we go. I have a point. I also need a tangent vector. And I'm going to go ahead and put this in here to help us out with lines. This is a directional vector. So I need to find the slope. That's practically what that is, right? Just described as a vector because we're going to work our way to 3 space. Struggling with this underline. Okay. So I have r prime. I just need to identify each one. So, and take my derivatives. X prime is, I'm going to go ahead and change this t squared plus 4 to the 1/2. That tells me x prime of t. I use the chain rule. So the 1/2 comes down. I leave the begin inside. I lower the power by 1. And then I times by the derivative of the inside, which is 2t. This is going to, 2's are canceling. I get a t on top. And then I get a square root of t squared plus 4. Sorry for my squiggle lines there. It gets kind of hard to write, make these little straight lines. So that's what x prime of t is. Let's find y prime. So y is, I avoid the quotient rule like the plague. So I like to bring stuff up like that. It's up to you. I'm going to leave it like that and do it the way I prefer. If you have a different way that you learned during Calc 1 and 2, I don't care as long as it makes sense mathematically. Okay, so the negative 1 comes down. I got t squared minus 1 to negative 2, went down by 1, times the derivative of the inside, which is our 2t. This gets me a negative 4t over t squared minus 1 squared. All right, we got one more. These get gross, but it's okay. Z of t is t squared. Now this one I think I'm going to do the quotient rule as a review. T squared over t squared plus 4. Okay, the quotient rule, the way I have it memorized is low d high over, minus, whoa, what's happening? My apologies. Minus high d low over low squared. So low, what I mean by that is if I take my derivative, c prime of t, all right, the low one is the expression on the bottom, so t squared plus 4, times the derivative of the top one, which is 1, minus the top one, times the derivative of the bottom one, which is 2t, all over whatever was in the bottom squared. All right, I like to clean this up. I'm going to go ahead and multiply this out up here so I don't have to rewrite a whole nother line. Okay, so we get minus 2t squared and then plus 4t. Okay, so minus t squared plus 4t plus 4. Sorry, my hands are all over the place. All right, I got t squared plus 4. All right, so that's what I get for z prime. It's not pretty, but that's okay. We can leave it not pretty. That's totally okay. So that's what z prime of t looks like. It's very gross, but I think it's all right. I'm double checking everything. Yeah, I think we're good. Okay, so if I want to, I have our prime of t now. It's all three of those. So I got t over t squared plus 4. And then I got negative 4t over t squared minus 1 squared. And then the last thing I got is negative t squared plus 4t plus 4 over t squared plus 4 squared. Oof. Okay. But that's okay. Even though it's gross, we can deal. Let's do r prime, and then the word, what they give us, 3 is what they're wanting. Yep. So I'm going to plug in a 3 here. Okay, so I get 3 over the square root of 13. I got negative 12 over 3 squared is 9, minus 1 is 8, 8 squared is 64. We could reduce that. What is that? Negative 6 over 32, which is a negative 3 out of 16. Okay. Negative 3 out of 16. And then the last thing, we got to plug a 3 into all that business. Okay, I got negative 3 squared. Be careful with that negative. 4 times 3 plus 4 over. That's going to be 3, and that's 9. It's a 13 squared, which is 169. Okay, so I got negative 9 plus 12 plus 4. So negative 5, 7 over 169. It's not pretty, but that's okay. If that number's wrong, I just did it in my head. Forgive me. Just fix it. It's okay. The arithmetic isn't that important in this case, right? Just the can you do the derivatives and plug them in. Okay, I also have a point of tangency that we had. Where'd that go? It was the square root of 13, 1/4, and 1/13. So they want the equation of the tangent line. So remember, equations of a tangent line we describe as parametric equations of x, y, and z. And then what we were going to do, okay, is radical 13 plus 3 over radical 13t. It was the beginning times the slope, right, which is our directional vector, t. So the next one's going to be 1/4 minus 3 over 16t. And then the last one is going to be 1/13 plus 7 over 169t. So there is my equation of the tangent line. Now, the numbers were not pretty here. That's okay. Just keep moving forward. Just be very careful with your derivatives, and know that you're just going to plug numbers in the end. So even if you don't want to simplify because you don't want to make that mistake of simplifying, don't. Leave it all unsimplified and then just plug in the t and question. Just be very careful with your arithmetic. All right, I'm going to do one more that's similar to this. Okay, equation of that tangent line. So we're going to have to find all these derivatives and we're going to have to do that sine one there. That's okay. So let's do this. X of t, they want the equation of the tangent line. Okay, so e to the t squared times sine to the t squared. All right, I'm going to do that right underneath because I think I'm going to need the room. I'm going to write out the power rule for you so you know where this is coming from, but you don't have to if you can do it without writing it. All right, this is what the power rule says to do. Okay, so the derivative of e to the t squared is 2t e to the t squared, chain rule, times sine of t squared plus e to the t squared times, okay, this sine rule, okay, it's going to be 2t times cosine of t squared. Is there anything? Yeah, I can factor out. I'm going to try to make our lives easier with writing and plugging in. I got, be very careful here. This is not the Pythagorean triple. The arguments, the t's are squared, not the sines and cosines. So that is the proper way to write that one. Right? Y of t is e to the negative t squared times cosine of t. Right? I'll write out the power rule. Y prime of t is the derivative with respect to t of e to the negative t squared times cosine of t plus e to the negative t squared times derivative of cosine t. All right, taking our derivatives, this is the same thing as earlier, we just have a negative. Yeah, we're going to have a negative come out of it. Okay, so we got a negative 2t e to the negative t squared, keep our cosine, plus e to the negative t squared, and then this was just a cosine of t in this case, I believe. Let me double check that. Yep. So derivative of cosine is negative sign, so I'm going to throw a sign there, and then I'll change the sign in between. This one doesn't really clean up too much. I guess we could do this if you really wanted to. Factor out a negative, and then I got 2t cosine t plus sine t. And that's really all we can do. It may help with plugging it in, though. Plugging something in. All right, z prime of t. That one was, let's scroll back up real quick, negative 5 inverse sine. All right, the derivative for this, I don't know if you remember this from Calc 1, this would be one that you'll have a table. This is going to end up to be, okay, negative 5 just is on top, and then we get 1 minus t squared in a radical. So there's the derivative of that weird inverse sign. You'll have a table for any assessments. All right, so we have that. So I want r prime of t. I'm going to write it out. All right, it was, I'm going to duplicate because I'm lazy. So I get this. Oof, okay, and then I'm going to shrink these down as I go about it. Okay, and then I have that. Let's do this for a moment. I'm going to shrink all that down to the same size. And then move this. There we go. And then we've got one more. It was the z, which was negative 5 over 1 minus t squared. There we go. Sorry for the sloppy handwriting. I'm trying to write really small right there. Okay, so that's what we have for r of t. I think the problem, let's scroll back up. The problem says at t equals 0. That's great. So r prime of 0 is equal to r prime. There we go. The first component, if I plug in a 0, I get a 0. Great. Second component, okay, this is a negative 1. So I'm going to have negative 1. Cosine of 0 is 1, but the t makes a 0. Sine of 0 is 0. I get 0. All right, and then the last one, we do have some kind of direction here. We got negative 5. So this line at 0 is literally going straight down. Okay, we need a point of tangency. So I need r of 0. So I'm going to go back. I got to zoom out, so forgive me. Zoom out. Okay, if I plug in 0 into the first one, I got 0. If I plug 0 into the second one, I get 1. Yep, cosine of 0 is 1, and then e to the 0 is 1. And then if I plug 0 into that, sine is 0 at 0. So we get 0. So this gives me a point, though. 0, 1, 0. So the equation of our lines will be x, y, z. And when we start at the point, I'm going to write in all these. I know it's silly, but 1 plus 0t, and then 0 minus 5t. You don't have to put any of those zeros. We really could have wrote x is 0, y is 1, and z is negative 5t. That would be good enough for our line. So this, our x's stay constant, our y's stay constant, but the z changes. All right, so there is the equation of our parametric line, or parametric equations of our line in 3 space.